applications of derivation, first part. Then next is that logarithmic.
First book and Z.
And after integrals, one chapter is there. Linear programming. Yeah, linear programming.
Okay, so first book and linear programming,
Yes.
not integration.
No.
Okay, then it's fine. So that will be completed, so it's fine for me. Okay, so Fahad, Rifat, and Abdul, can you tell me when you have your exams and the syllabus? Fahad, Rifat, Abdul, my voice is audible.
Good evening, sir.
Okay, good evening. Yes, Fahad.
So school said that from next month they will take unit test, which is
Okay.
of 20 marks.
Okay.
And about syllabus, they didn't say anything.
Okay, how many chapters you have completed in the school?
In school, this applications of derivatives is going on.
Is going on. So they have completed 5 chapter and the 6 is going on.
Yes, sir.
Okay, then it's fine because today we will complete this chapter and start the inverse as well. So you will not face any issue in the exam. Okay, Rifat, so I got your message. Okay, so your unit test is in October. And how many chapters, Rifat, you have done in your school? 5 chapters. So 1 to 5? Rifat, 1 to 5 chapters? Rifat, please reply me, okay? And Abdul, when, okay, so, okay, Abdul, you married to the school, can say parents and complete the portion till November. We are lying behind, they will keep 4-5 pre-boards. Okay, so Abdul, how many chapters you have done in your school right now? Okay, okay, Rifat.
Differentiation.
Up to differentiation.
Yes, sir.
Okay, so then I think our syllabus is fine because we are doing application of derivative.
Yes, sir.
Okay, okay, but they will complete the complete book till November.
Yes, sir. That's what they're saying.
Right now, which chapters you are doing?
So we are at the end of the derivatives.
Application of derivative?
Yes, sir. No, sir. Differentiation.
Differentiation. Okay, okay, then it's fine. Okay, then we will start this topic. I guess in the last class, we have already completed the first derivative test. It was done in last class. Abdul, we have completed that. Abdul, Fad, Rifat. Okay. Can you tell me? I guess we have already completed the first derivative test in the last class. Please confirm.
Yes, sir.
Okay, okay. Then only two topics are remaining. First one is maximum and minimum values of a function in a closed interval. Okay. So what does this mean? While when we were doing the local maxima and minima, I already told you that local maximum is not the maximum value of a function. For example, here we can see that it is local maxima. Okay, it is local maxima and this is local minima. This is local minima. Okay. So here we can see that local maxima is okay, Fahad, thank you. So here we can see that local maxima is not the maximum value of a function. Okay. Yes, yes, that's correct. Okay, from the graph only you can see that local minima is even greater than this local maxima. Okay, so local maxima means the value is greater than the neighboring values. Now, the topic is maximum and minimum value of a function. So you need to find the maximum and minimum value of a function. Okay. So how we will do these types of questions? Here they will give you the interval. So for example, this interval, this is 1, and this is, for example, this is 7. Okay. If we will check that maximum and minimum value, then in a function, the maximum and minimum value we can get at which point? At the critical point. I guess you all know what is the critical point. So the maximum and minimum value can exist at the critical point. That means this one, this one, this one, you said this one, this one. Okay, so maximum and minimum can exist at the critical point or at the end point. For example, this. Okay, then from this graph, you can see that the minimum value is at x is equal to 1. Minimum value of a function exists at x is equal to 1, and the maximum is this. So where is the possibility of finding the maximum and minimum value? Either at the critical points or at the end points. Okay, so here we don't need to find local maxima and minima, so there is no need to use first order derivative test or the second order derivative test. Okay, here they will just ask you that find the maximum and the minimum value of the function. So what you need, first you need the endpoints as well as these critical points. So who can tell me how can we find the critical point? First, can you tell me how can we find a critical point in a function? Fahad, can you tell me how can you find a critical point in a function? Fahad, oh, you forgot. Okay. Who can tell me? Abdul? Yes, yes, that's
Putting f of x as 0.
yes. Okay, if you have a function, Fahad, I guess you are confused. So you need to find derivative of this and just equate that with 0. Okay, so whatever the value of x you will get from this equation, those all are the critical points. Okay, and remember one more thing. If you have a function like this is the derivative. Suppose if you differentiate something and you get like this, then you need to equate numerator to 0 as well as denominator to 0. Okay, because if the denominator will be 0, then this will not exist. So we need to find both the points. And I hope we have already discussed why is it so. Okay, so you need to find the critical points as well
So
as
we should
the
equate the both numerator and denominator with 0.
yes. Why? Because see here, it is a corner point. Okay. And in differentiability, we have already checked that at the corner point, the function is not differentiable. Okay. But this is also a local maxima and the local minima. So to find the critical point, you need to equate both numerator to 0 as well as the denominator to 0. Because when you will put denominator to 0, then for that point, the derivative of the function is not differentiable. Okay. So we need both the points. So, okay, again, go back to this graph. What we need the endpoints, which will be given in the question. We need the critical points. You know how to find this. Once you will get all these points, then put the value. For example, if you have this function x squared plus 1, you have these endpoints. And if I will say to you that this is your critical point, 2, 3, this is 4, okay, 5 and 6. So these are your critical points. So you need to put the endpoints in the function. You need to put the critical points in the function. Then whatever the value of the function you will get, from that you need to decide that what is the maximum and the minimum value of the function. Okay, so while finding the maximum and the minimum value, there's no need to put the first order derivative test or the second order derivative test. You just need to find the critical points. You just need to put the endpoints in the function. Then you need to check what is the maximum and the minimum value you are getting. Okay, so I think you don't need this graph. So I'm going to erase this. I will give you the points. So how you need to find the maximum minimum value. These are the working rule. First, find all the critical points of f in the interval. Okay, you know that what is a critical point where the derivative is 0 or function is not different, or f dash is not differentiable. Okay, where either f dash x is 0 or f dash x is not differentiable. Next, take the endpoints of the interval. Okay, After that, all these points, which point? Critical point as well as the end points. Calculate the value of f. Identify the maximum minimum value which you're getting. We have already discussed this. Okay, so please note down this. Raise your hands once it is done. Then we will solve 2 questions. Then this topic will be completed. Okay. Okay, that's very good. Abdur, Fahad and Rifat, please raise your hands once it is done. Okay, Rifat, very good. Abdur and Fahad. Okay, Abdur, good. Fahad, is it done? Someone has sent the message. Okay, Fahad. Yes, Fahad. As you have done in local maxima and minima. Okay, so in the second order derivative, we first find the critical point. So for critical point, you need to equate that with 0, as well as, for example, if you have x minus 1. So if you will equate this with 0, then you will get only a single point. If you will equate this with 0, so you will get only x minus 1, 0, because you need to cross multiply, you will get a 1. But that's why I'm saying that you need to equate to 0 numerator as well as denominator. If you have a fraction, then equate numerator and denominator separately to 0. Is it clear, Fahad?
Yes, sir. Done.
Okay, great. Now this question. Okay, we need to find the absolute maximum and minimum. So absolute is also the same thing. You need to find the maximum and the minimum value of the function. You have this interval 1 and 5. Okay, from 1 to 5. So first find the critical points. So everyone please complete this and tell me what the critical points you're getting. Okay. And Zed, you have an exam on 24th. So let me check. Today is 10th. So please remind me next week, Zed. Or Zed, is it fine if I will share the recorded lectures of LPP with you? Okay, great. So LPP is a simple chapter. I will share the lectures. Thanks. Yes, so everyone, please find the critical points and share the critical points with me. Then I will tell you that how you need to solve the questions. First one, okay, one you are getting, that's fine. But 4 is not the critical point. I guess you have done some mistake. You need to differentiate it, okay? Please differentiate it and then equate this to 0. So if I will write here 2x cubed minus 15x square plus 36x plus 1. Very good, Zad. That is correct. Now, Zad, just give me a minute. So this is 6x square minus 30x plus 36. We don't have a denominator here, so we will put this to 0. Equate this with 0. So 6x square minus 30x plus 36 is equal to 0. Divide this with 6, so you will get x square minus 5x plus 6 is equal to 0. Now break the middle one. So x square minus 3x minus 2x plus 6 is equal to 0. So take x, so x minus 3 minus 2, x minus 3 is equal to 0. So here x minus 2, x minus 3 is equal to 0. So what you will get here, x is equal to 2 and 3. Okay, so for where you have done the mistake. Fahad, where you have done the mistake. Okay, Fahad. So you get these two critical points and endpoints are 1 and 5. So you need to put these values in the function, not in derivative. Okay, so you have 1, you have 2, you have 3, you have 5. Put all these points
So
separately
we
in this.
put it in intervals like in number line.
No, Abdur, there's no need to do that. Okay, because we don't need to find the local maximum minimum. We need to find the maximum value of the function. So points, if you will apply a simple logic, then points you already get. Now you need to put these points in the function. Okay, what the maximum value you will get, that will be absolute maxima. Is it clear, Abdur?
Yes, sir.
Okay, now you have 4 points. Please put these points in the function and tell me what the maximum and the minimum value you are getting here. Very good, Zia. That is correct. And what's the minimum value?
So should we put the values of 2 and 3 in f of x?
Yes, you need to put all these values 1, 2, 3, 5 in this function fx. Okay. And then tell me what the maximum and the minimum. Very good, Zia. That is correct. Very good. Everyone, please share your answer if you get it. Very good, Fahd. It is correct. Abdur, for 1, you are getting 24. That's correct. For 2, no, Abdur. For 2, you will get a 29. Okay. Please again check the calculation. And no, not for derivative. For you need to put in this function. Okay. So from derivative, you just need the critical points. So critical points as well as the endpoints. You need to put all these points in this function. I need to check the answer. Okay, Fahd?
Yes, sir.
Okay. So please complete it and share the answer. Rifat, is it done? Rifat, is it done? Okay, great. Rifat, will you please tell me the maximum and the minimum value? Very good. That's correct. Words, very good. Okay, and always write the point that absolute maximum value is this at x is equal to this point. Okay. Okay, so who's left? Fahad and Abdul, please let me know once you complete it. Very good. Fahad, no, Fahad. Uh, Abdul, you just need to put the points in this function. Okay, we have find out the critical points. So start with 1. In this fx, put 1. So what you will get? 2x cube. Sorry. Okay, just right here. 2 1 cube minus 15 1 square plus 36 into 1 plus 1. So this is 2 minus 15 plus 36 plus 1. So what you will get here? 39 minus this. So here you will get a, I guess, no, 24. Okay. So here you get a 24. So now please put these points F2, F3, and F5. Okay. And tell me what the values you are getting. For the F2 is 29. That's correct. But F but 29 is not the minimum value. Okay. F3 is 28 for very good. This is correct. So further find out this. F2 is 29. F3 is 28. That's correct. Now please find F5. I will tell you later on further. Please find the value F5. And Abdur, please check these values and confirm me. Okay, just put this F5. So what you will get here, 2 into 5 cube minus 15 into 5 square plus 36 into 5 plus 1. Very good. For that is correct. So F5 you are getting 56. So what's the minimum value here for?
24.
24. Very good. So this is a minimum value at x is equal to 1. Then this is a maximum value at x is equal to 5. Is it clear for?
Yes, sir. Now it's
Okay.
clear.
Great, great. Abdul, is it done?
Yes, sir.
Okay, great. So one more question from this type. Okay. Yep, this one. Find the absolute maxima and maximum and minimum values of this function. Okay. So first of all, please tell me the critical points in this function. Please start this one and tell me the critical points. Zed, will you please tell me what the critical point? Okay, 1 by 8. But Zed, there's one more critical point. Okay, please check your expression. You will have one more critical point. Very, very good, Zed. It is correct. Very good. Now you understood that for 0, it is not differentiable. That's why both are the critical points. Very good. Fahad, Rifat, and Abdur, please share the critical points if you have solved this. No, there's no need to differentiate 2 times. Okay, in the maximum and minimum values, there's no need to differentiate. You need to find the critical points. Okay, I will solve this for you. So, and tomorrow you have a test of maxima and minima. Okay, so 12x 4 by 3 minus 6x to the power 1 by. Very good, Rifat. It is correct. Now you understood that for 0, this function is not differentiable. Okay, let me solve this one. 12 into 4 by 3 x to the power 4 by 3 minus 1 minus 6 into 1 by 3 x to the power 1 by 3 minus 1 Here we will get f dash x. It is equal to, cancel out this 3, 4, 16, x to the power 4 minus 3 is 1 by 3, minus, cancel out this 2, x to the power minus 2 by 3. Okay. So here please write f dash x it is equal to 16 x to the power 1 by 3 minus 2 by x to the power 2 by 3. Okay. Then take the LCM. So what you will get here, f dash x it is equal to, take the LCM. LCM is what? X to the power 2 by 3. Here you will get 16 x to the power 1 by 3 into x to the power 2 by 3 minus 2. So here you will get f dash x. It is equal to 16 x to the power. Add the power, so you will get 1 plus 2 x minus 2 by x to the power 2 by 3. Okay, so please check. This is in fraction. So you need to equate the numerator and denominator both to 0. Okay, so Fahad and Abdur, now please tell me the critical points which you will get here. No, Fahad, that is not 8. That is 1 by 8. Okay. Okay, Fahad. Now please tell me one more critical point. For the for the numerator part, you will get 1 by 8. Okay. So equate 16x minus 2 is, and very good, Abdur, it is correct. And x to the power 2 by 3 to 0 to find the critical points. So here you will get 16x minus 2 is equal to 0. So x is equal to 1 by 8 and x to the power 2 by 3 to 0. So you will get x is equal to 0. So you get these 2 points, these 2 values. Okay. Now, please put, now you have 4 values, 1, 2, 3. And next is this one, x is equal to 0, 4. So you have 4 points. Please put all these points in this function and tell me what the maximum and the minimum value you are getting. Okay, Abdur, you are getting 18. Very good, Abdur. Sorry, Zed. It is correct. Very good. Now, please tell me the minimum value. Abdur, here the base is same. Okay, base is same. So if you will multiply this, then power will get add up. So 1 by 3 plus 2 by 3, which will give you 3 by 3, which will give you 1. Is it fine, Abdur?
Yes.
Okay. Zed, very good. It is correct. Okay. Rifat, is it done? Did you get the maximum and the minimum value? Rifat, is it done? Max is 18. Very good. Good. Fat, please find rest of the values. Which problem, sir?
So maximum minimum.
We have already completed. Word problems we have already done.
Sure.
Okay. Good, Abdur. That is correct. So you need to find the values for all the points. So you have find out for -1. Very good. For -1, you are getting 18. Now similarly, find for 0. Next value is find for 1. Next, find for 1 by 8. So once you will get all the values, then you need to decide that what is the maximum and the minimum value. Okay, Abdur?
Okay, sir.
Okay, please complete this. Share your answer. I can't find for -1. Why for? I will change the slide for. So we have this fx is equal to 12x to the power 4 by 3 minus 6x to the power 1 by 3. Okay, so we have this value. Now we need to put all the -1 here. So what you will get 12 into -1 to the power 4 by 3 minus 6 x to the -1 to the power 1 by 3. So what you will get here 12. This can be written like this: -1 to the power 1 by 3 to the power 4 minus 6 to the power -1 1 by 3. So this is 12. If you will find the cube root of -1, you will again get a -1. Here you have power 4 minus 6. Here you will get a -1. So here you will get 12 minus plus 6. It is equal to 18. Is it fine, Far? Fard, is it fine? So please note down this Fard, find rest of the values and tell me what the maximum and the minimum values you are getting. Okay. Very good, Abdur. It is correct. For x is equal to 1, you have 6. Good. Okay, I guess the last point left is 1 by 8. So please find the value for 1 by 8 also. Minimum value is not 0. What the value for 1 by 8, Abdur? Yes, for 1 it is 6. Good. For Abdur, what is the value for 1 by 8?
So I found the value for 0 is 0, right, sir?
Yeah, for 0 it is fine. But please find for 1 by 8 also. Okay. Abdur and Fahd, is it done? So let me complete this. 12x to the power 4 by 3 minus 6x to the power 1 by 3. Okay, so put this value of x, put f1 by 8. So what you will get 12, 1 by 8 to the power 4 by 3 minus 6, 1 by 8 to the power 1 by 3. So write it like this, 12, okay, 1 by 8 to the power 1 by 3 to the power 4 minus 6 to the power 1 by 2 to the power 1 by 3. Sorry, this is 8. This is equal to 12. And 1 by 2 to the power 1 by 3 is 1 by 2. 4 minus 6. This is 1 by 2. Okay. So this is equal to what? 12 into 1 by 2 means 1 by 16 minus 3.
So how we got 1 by 2?
What is the cube root of 1 by 8?
Yes, sir, 2.
Okay. So do this 4, 2, 4, 3. So 3 by 4 minus 3. So what you will get here, 12 minus 3 is minus 9 by 4. So minimum value is minus 9 by 4, which is at x is equal to 8. And the maximum value you have already find out, which is, I guess, it is 18. For 0, for 1 you get a 6. So the maximum is 18 for x is equal to minus 1. Is it clear? Further, Abdur?
Yes,
Okay. Abdur, is it clear?
yes, sir.
Okay, then we will, so this topic is complete, absolute maximum minimum. Okay, only, further, you have a doubt in this? Okay, what's the doubt? Always remember, if you have a fraction, power is in fraction, so then first of all, try to solve this one, cube root. So cube root of 1 by 8. So we can write this 1 by 8 like this, 1 by 2 into 2 into 2. Then you have a cube root, which will give you 1 by 2. Okay, Fahd? Okay, so this topic is almost completed. We have done this. Now the last topic is we will do quickly some of the questions. Then your chapter is complete and we will start inverse today. Okay. Okay, so we have already discussed this. Okay, there are some questions which actually these questions were there in the starting of the chapter. Okay, so to explain to you about the maximum and the minimum value. Okay, so we will try to solve some questions. For example, first of all, we will do this fourth one, mod x plus 2 minus 1. First of all, everyone, please tell me. mm, yes, Abdur, these can be done by the second order derivative also. Okay, but these questions were given in the starting of the chapter. So we will do in the same way. So first of all, we will do 6th question. In the 6th one, we have sine 2x plus 5. So how we will do this directly? 6th one. Sine 2x, you know what is the maximum value of sine and what is the minimum value of sine? This one. The sinusoidal function, the maximum value is 1 and the minimum is minus 1. Okay, so we will write in this way. Sine 2x should be greater than equal to minus 1 and less than equal to 1. Then change this expression as per your question. So in the question you have a 5. So here write sine 2x plus 5 less than equal to, okay, add, that means we are adding the 5 on both sides. So let this be 1. Add 5 and 1. So we will add 5 here, sine 2x plus 5 less than equal to 1 plus 5, greater than equal to minus 1 plus 5. Okay, so here we will get what? 4 less than equal to sine 2x plus 5. And here you have less than equal to 6. So who can tell me what is the maximum and the minimum value of this function? Who can tell me the maximum and the minimum value of this function? Very good.
6 and 4.
Very, very good. Okay, so good said. Good for. So maximum is 6 and minimum is 4. So we can say maximum value is 6, minimum value is 4. Okay, in the same way we can do the seventh also. So what is seventh? Seventh is fx is equal to mod sine 4x plus 3. So you need to do the same thing, sinusoidal function. So the maximum value is, minimum is -1, maximum. Yes, Abdul, the same method, the second order derivative. Okay, second or first, you can apply any of these methods. Okay. So, but these questions were given in your book by this method, so I'm solving this. So again, sinusoidal is less than equal to 1, -1 and 1. Sorry, less than equal to 1. Now change this expression as per your question. So you need +3 here. So add 3 here, add 3 here. Okay, less than equal to 1 plus 3. So what you will get here? 2 less than equal to sine 4x plus 3. Here you will get a less than equal to 4. Now what we need a modulus. So take a modulus on all these. Okay. So here mod of 2 is 2. This remain as it is, sine 4x plus 3 less than equal to, it is 4. So I will write the answer here. Maximum is 2. Sorry, maximum is 4. Minimum value is 2. Minimum value is 2. Okay. So please note down this. Raise your hands once it is done. Then we will do one more question. Then this chapter is complete. Okay. Okay, Zed, very good. Whose doubt is this? Okay. So Abdul, please remember that if you have a trigonometric function, whatever the angle you will put in the sign. First of all, Abdul, please note down this. Okay, because I need to change the slide in order to explain to you. Okay. So Zad has done this. All of you, please raise your hands once it is done. First, I will show this from the graph. Okay, please note down this. Raise your hands, then I will draw the graph because I need to change the slide then. Okay, Fahad, good. Abdul, please raise your hand. Rifat, is it done? Okay, Rifat, good. Abdur, is it done? Abdur, is it done?
Yes.
Okay, great. So please check here. Suppose you have sine x, you have sine 2x. So whatever the value you will put here in place of x or Abdur, I don't know whose doubt is this. For example, x you are putting here 30. So what you will get here? Sine 60. So it is still a sinusoidal function. So whatever the angle you will put here, it will behave with sine. So what is the maximum value of the sine? It is 1. So whatever the angle you will put here, even if you will put, for example, 360 or anything, then it will become 360 into 2, which will give you sine 720. But it will give you the value which is there in the sine. Okay, so the maximum value will remain 1 only, whatever the angle you will put here. Angle can be anything, but the value will remain 1. Similarly, the minimum value is 1. Okay, so here if you will write 2x, you will write 3x, you will write 100x. Maximum and the minimum value of the function will not change. Is it clear, Abdul?
Yes, sir.
Okay, and for next your doubt, you're saying why it is, this is a sinusoidal function. Okay, so the maximum value of this is 1 and the minimum value is -1. That's why we have taken 1 and -1. Is it clear? Further?
Yes, sir.
Okay, great. So almost done. We will do just one more question and then we will start a new chapter. Okay, so we will take a fourth question, x plus 2 minus 1. Fx is equal to mod x plus 2 minus 1. So first, please tell me if it is a modulus, then what is the maximum value? Okay, please check here. You have mod x plus 2, so we can say mod x plus 2 is always greater than equal to 0. Okay, the modulus is always greater than equal to 0. Modulus can't be negative. You already know this one. Okay, so now change this expression as per your question. So here you have -1, write -1 here. -1, and same thing you need to subtract on the right side also. Okay, so what is this? This is your original question, fx. So fx is greater than equal to 1, -1. So who can tell me the minimum value of this function? Who can tell me the minimum value of this function?
The -1.
Very good, very good. So the minimum value is -1. Okay, and when we will get a -1, when this will be 0. When this will be 0 at x is equal to, this will be 0 for x is equal to what? Mod x
-2.
-2. Very good. At x is equal to -2. And this function do not have any maximum value, okay? Because fx is greater than equal to -1. So this do not have any maximum value. Minimum value is -1. Okay. In the same way, we will do one more question. Minus mod x plus 1. Fifth, fx is equal to minus mod x plus 1 plus 3. Okay. So we will try this question again. Start with, yes.
So in these questions, we don't have to apply the first derivative, right?
No. Actually, these questions were given in the beginning of the chapter to just explain to you that what is a maximum and minimum. Okay, so Abdur, these questions are there in your book. That's why we are solving it. But please focus much more on the second order derivative and the first one. So most of the questions will be asked from there only. Okay.
Yes, sir. Thank you.
Okay, you're welcome. So just do in the same way. This is greater than equal to 0. Multiply this with negative. So sign will change. Add 3. So you will get minus x plus 1 plus 3 less than equal to 3. So this is what this is fx. Fx is less than equal to 3. Okay, so maximum value is, so here we have maximum value. Maximum value is 3. Very good, Zed. And when we will get 3, when this will be 0. So at x is equal to minus 1.
-1.
Yeah, very good. Okay, so please note down this and raise your hands. So our chapter is complete. I'm again saying that the word problems are very, very important. The second order derivative rule is very important. Okay, so if you have not done the homework, please complete the assignments. All the problems, all the word problems which are given in NCERT. Okay, those are very, very important. We can expect even a direct question from the word problem. Okay, please don't miss that. Please try to complete the homework and let me know in case you have a doubt. We can discuss after the class. Okay, so please note down this. Raise your hands. We will start the inverse trigonometric function. Okay, Fahad, very good. Okay, Zed. Okay, Abdur, good. Rifat, is it done? Okay, great. So, yes, Abdur. From NCERT only, the word problems are very, very important. Okay. Okay, then we will start the inverse trigonometric function. After relation and function, we have directly started the differentiation. Okay. So there are some topic from the relation and function which we need here. Okay. First thing we will see what is the inverse of a function and in which case inverse exists. So please check here. Corresponding to every bijection. Now, what is a bijection? I guess you might forgot that. Okay, Fahad. We will do some basics of trigonometry first. Okay. We will do graph, everything we will do. Okay, so first of all, we will again revise that bijection which we have done in relation and function. So I hope you remember 1, 1 and onto function. Okay, what is a 1, 1? When all the elements have different images. No, Zed, we have not done the inverse yet. Okay, after relation and function, we have started differentiation. Okay, so this chapter was left. So suppose you have two functions, you have a function from A to B, and this is both 1, 1 and onto. What is a bijection function? Which is both 1, 1 and onto. So if you have these two values, A1, A2, A3, here you have B1, B2, B3. A1 is mapped with B1, A2 with B2, A3 with B3. Okay, so this is a bijective function. Okay, which is both 1, 1 and onto. So if a function is bijective, then you can find the inverse of this. Here, this is a function from A to B. What is the F inverse? F inverse will become B to A. Okay, so what you will get here? B1, B2, B3, and here you have A1, A2, A3, B1 is mapped with A1, B2 with A2, B3 with A3. Okay, so if a function is bijective, then only its inverse will exist. So what is a bijective function? Which is both 1, 1 and onto. Okay, where A1, A2, A3 have the different images and all the elements which are there in B have the pre-images. So this we have already discussed in relation and function. So when the inverse will exist, when the function will be bijective function. Okay, if a function is bijective, then only its inverse exists. If it is not a bijective, then its inverse will not exist. This is clear to everyone. This is a very important statement. Please raise your hands if this is clear to you. Good, Fat. Abdul, Rifat, and Zad, is this clear? Good, Rifat. Abdul? Good. Zad? Okay.
So what
So
is into function?
we have started with 1 onto. Into is opposite of this onto. Okay. If a function is not onto, it is an into function. Okay. That means there are some image elements here which do not have their pre-images. Okay. Okay. So corresponding to every bijective function, there exists another function. Please check here. This f a to b is a bijective function. If this is a bijective, then there exists another function b to a. Earlier we have a function a to b. Now we have a function b to a defined by gy is equal to x and let me solve and fx is equal to y. The function, this one, b to a, is called the inverse of the function and it is denoted by f inverse. Okay. So if you understood this line only, then this is enough for me. Okay, only this one. So if only this till here. So corresponding to every bijective f a to b, there exists a bijective function b to a. So I'm saying this, that if you have function a to b, which is a bijective function, then there will exist a function b to a. And this b to a function is called the inverse of f, which we have checked in the previous example. For example, if we have a function a to b, here you have b, here you have a1, a2, here you have b1, b2. So a1 is mapped with b1, a2 with b2. So this is a bijective. That's why its inverse will exist, which will become opposite of this. So first you will have a b and then you have a a. B have the same element b1, b2. A have the same element a1, a2. Okay, b1 with a1, b2 with a2. Okay, so if a function is bijective, its inverse will exist. Inverse will be opposite of f. This is clear to everyone. Please raise your hands if it is clear.
So, sir, in the question, will
Yes,
it be
sir.
written as it is bijective?
Question will be quite simpler. Okay, they will not give you bijective. They will just tell you that find the inverse of
For inverse.
yes. So we will do the trigonometric functions. Okay. I will just explain to you later on. Okay.
Okay.
So once we will do the graph and the domain and range, I guess this problem will be solved on its own. So everyone, please raise your hand if this is clear to you and note down this. Okay, then we will start the domain and range and graph of inverse trigonometric. Okay, Fahad. Okay, Abdul. Rifat and Zed, please confirm if it is done. Abdul, onto means in the second set, this one B, all the elements have their pre-images. Okay, if I will write here B3, which do not have its pre-image in set A, then this will not be a onto function. Is it clear?
Yes.
Okay, great. So everyone, please raise your hand if it is done. Rifat and Zed, is it done? Okay, I hope everyone has done this. So we will start the next topic. Okay. 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 Next we have let's discuss about the trigonometric functions. First we will discuss all the basics here. Okay. So let x is equal to sine theta be a function, then its inverse is theta is equal to sine inverse x. Okay. So if you have x is equal to sine theta, then we can write sine theta is equal to x, and then we can write theta is equal to sine inverse x. Okay. So if I will give you a function, a trigonometric function, and you need to find its inverse, how you will do? You will do in this way. So if x is equal to sine theta, then its inverse is theta is equal to sine inverse x. Okay. Okay. So, okay. Let, I guess you have a doubt in bijective function, bijection. Okay. First, we will again discuss 1, 1. So I will give you 2 cases and everyone, or I will give you 3 cases. You need to tell which is a 1, 1 function from these. This is first, this is second, and this is third. This is A to B, A to B, A to B. Sorry, this A, this B, this A, this B. So A1, A2, A3. Here you have B1, B2, B3. A1 image is B1. A2 is also B, this one. Then A1, A2. This is first one. A3. Next you have B1, B2, B3. Then A1 with B1, A2 with B1, A3 with A3 is also with B1. Last one, A1, A2, A3, B1, B2, B3. Okay, this with this with this, and this with this. So the third one. Okay, my question was which is a 1, 1 function. So this third one is a 1, 1. Why it is not 1, 1? Because 2 elements have the same image. So what is a 1, 1? When different elements should have a different image. So this is not a 1, 1 because A1, A2 have the same image. This is also not 1, 1 because A1, A2, A3 have the same image. Okay. I will take one more case. Please tell me this is also a 1, 1 or not. Here we have A, here we have B, and this is the fourth one. Okay. So we have A1, A2, A3, B1, B2, B3, B4. So A1 is linked with B1, A2 with B2, A3 with B3. Please tell me this fourth one is 1, 1 or not. Everyone, please tell me this fourth one is 1, 1 or not. Zed, will you please again check? Fahad, Abdur, Rifat.
Yes, sir.
This is 1, 1.
No,
Okay.
sir.
No, it is not. Okay, Zed. Fahad, is it 1, 1 or not?
So which one?
The fourth one? This?
No.
It is not. Rifat, is it 1, 1 or not? Rifat, this function is 1, 1 or not? Yeah. Abdul, why is it not 1, 1? So A1 have a unique image. A1 have only one image B1. A2 also have one image. A3 also have B3. So why this is not 1, 1 for her than Abdul?
Sir, it has an extra
Yeah,
element in
but
the
that, yeah,
domain.
yes, that not in domain, in this one, codomain. Okay, so that is fine. In set B, you can have an element which do not have its pre-image. Okay, we are discussing just about 1, 1, not on 2. So what is the definition of 1, 1 when all the elements have different image? So here we don't have different, here we don't have different. But if we will see here, then A1 have a different image, A2 have a different image, A3 have a different image, then yes, it is 1, 1. Okay. So the fourth one and the third one are 1, 1 function. Now we will check the second one, which is onto. Second is onto function. Okay. So what is onto? When all the elements which are there in set B have its pre-image in set A. Okay. Now please tell me which of these are onto.
Third one.
Third one. Good for. Okay. So if you will check here, then here all the elements have its pre-image. Similarly, if you will check here in B, then B4 do not have its pre-image. So this is not onto. If you will check here, B3 do not have its pre-image, not onto. B3 do not have its pre-image, not onto. Okay. So what is onto? When all the elements here have their pre-images. Now, what is a bijection which is both 1, 1 and onto? If we will check this third one, it is 1, 1 because A1, A2, A3 have different
The
image.
third one is bijective.
Yes, the third one is bijective. Okay. So when an inverse will exist when all the elements have, sorry, when the function is a bijective function. I hope now this is clear to you. Now we are studying the chapter inverse trigonometric functions. So first of all, we will check that our trigonometric functions are bijective or not. Okay. So we have this x is equal to sine theta. We will check this. So I will draw a set A and we will write its value here. B. So suppose if I will put 0, I will write pi by 6. I will write pi by 3 and I will write 2 pi. Then who can tell me what is the value of sine 0?
0.
Very good. So 0 will be mapped with 0. Pi by 6 means 30. What's the value of sine 30?
1/2.
Very good. 1 by 2. What's the value of pi by 3? Sine 60?
Root 3/2.
Very good. Root 3 by 2. What 2 pi? Sine 360 is what?
0.
Very good. It is 0. Okay. Now, please tell me this function is bijective or not?
No, sir.
No. Okay. So sinusoidal function is not bijective, but our chapter name is inverse trigonometric function. So how we are finding the inverse trigonometric function? We will try to understand the same thing from graph also. Okay. If we will draw the graph of the sinusoidal function, and the graph will be like this. Here you have a 0. So draw the graph. This is 0. So the graph of sinusoidal function is like this. Here you have like this. Okay. So here you have 0. This is pi by 2 because at the pi by 2 you have the maximum value which is 1. Then here you have what? Minus pi by 2. And here you have minus pi. Here you have minus 3 pi by 2. Okay. So if we will check this, okay, this will be 1. Okay. There's a rough sketch. Now please check here. Here we have written all the angles and here you have the values. If we will check this, this is 0 and this is 2 pi. So for 0 and 2 pi, you have the same value, which is 0. So that's why it is not bijective function. Okay. So throughout this graph, you can see there are many angles for which you are getting the same value. So definitely the sinusoidal function is not bijective. But if we will take just a portion, for example, from here to here, we will take only this portion and we will analyze this, then we can see that this portion is bijective function. What is this portion? If we will take angle from minus pi by 2 to pi by 2. Okay, from this graph, we will take the angle from minus pi by 2 pi by 2, then this portion is bijective. what angle we will take? We will take from minus 90 to 90. So just check here, from here to here, you will get all the different values. If you will check values, you will get on the y-axis. So check here, all these values are different. So how can we find the inverse of inverse of trigonometric function? We need to take just a portion from the graph. Okay, then only we can say that our trigonometric function are bijective for that portion, and then we can find the inverse of trigonometric function for that portion only. Okay, now the question is, can we take any portion? For example, Abdur can take this portion minus pi by 2 pi by 2. Next, Fahad will take the next portion from pi by 2 to this one. What is this? This is 3 pi by 2. Fahad will take this portion. Rifat will take another portion. For example, minus 3 pi by 2 to minus pi by 2. Zed will take another portion. So is it possible? Yes, you can do, but there should be some standard. Otherwise, what you will do, you will take another portion, you will do the calculation, all your answer will be different. So there should be some standard. So that standard is principal branch. Okay. So I hope now it is clear to you that trigonometric functions are not bijective. But how can we find the inverse of trigonometric functions? By taking a portion from the graph. From the trigonometric function, we will just take a portion. Okay. So, okay. Now the same thing which we were discussing here, sine inverse is what? Sine inverse is a function whose domain is -1 to 1. This point we will discuss again from the graph. Okay. And range could be any of these interval. So you can take any interval, this, and this, but we should have some standard, and that standard is principal branch. We will discuss that later on. Okay, I'm raising this graph. I will again draw this. Okay, so as I already told you that if you need to find out the inverse trigonometric function, then there should be, you need to take a portion. So that portion can be this, that portion can be this, that portion, you can take any portion. But we should have some standard. That standard is this, that the branch with the range minus pi by 2 to pi by 2 is called the principal value branch for sinusoidal. This is for sine theta. Okay, so whenever we will find the inverse of sine function, then we will take only this branch minus pi by 2 pi by 2, and this standard is called the principal value branch. So you need to learn all these. Okay, so for the inverse for sinusoidal function, please learn this, that minus pi by 2 to pi by 2 is called the principal value branch. Please note down this, raise your hands once it is done. Okay, then I will
Can
draw
you
the
explain second line?
third line. Yeah.
Second line, sir, second.
Okay, second line, the same thing which I was telling on from the graph, that you can take any portion. For that portion, the graph will
No,
be
sir, the domain.
okay. Domain, this I will do later on. Okay, so one by one we will discuss all the trigonometric functions. We will draw their graph. We will discuss domain and range. Okay, fine. So please raise your hands once it is done. Then we will do the graph. Everyone, please raise your hands if it is done. Okay, Abdur, good. And Fad, please don't worry. I will explain to you each and everything. Okay, domain range, everything. Okay, Rifat. Fad and Zed, is it done? Okay, good. Zed. Okay, great. Next, graph of inverse trigonometric function. So first of all, we will draw the graph of trigonometric function. First is x is equal to sine theta. Okay, you know that this is a sinusoidal function. So first of all, we will draw the graph of sinusoidal function. Like this. Okay. If anyone have a doubt, please let me know. Okay, we are doing from the basics. Okay, so this is 0. This I will write pi by 2, 90 degree, and this is minus pi by 2. This value is 1, and this value is minus 1. Okay, so now we will go back to domain. That what is the domain of a function? Who can tell me?
So minus 1 and 1.
No. Who can define the domain? Anyone can tell me? Last year you have done domain, then I guess in relation and function also we have discussed the domain and range. So who can tell me? Who can define? Yes.
All the first elements.
Sorry, Abdul. Will you please
The
again?
set of all the first elements.
All the first element. Very good, Abdul. That is correct. Very good. When we will draw this one, this is A, this is B. Okay. So all the elements which are there. Okay. Now, what is a domain? Okay. So what are the points we will write here? The theta, the angle. All the angles you will write here, 0, pi by 6, pi by 3. So your answer is correct. Now, what is the domain? The value in which you can put in place of theta, for which you will get a real number. Okay. So in place of theta, the values which you can put is the domain. So domain is what the value you can put. What is the range? When you will put this value, what the answer you will get. For example, if you will put a 30 degree here, then x will be equal to 1 by 2. So 1 by 2 is one of the range. So what is the range? Output. When you will put the theta, what the answer you will get, that will be the range. What is the domain? What you will put in place of theta? What real number you will put in place of theta so that the final answer will be a real. That is the domain. So this definition is clear to all of you. Abdul Fahd Rifat Zad, please raise your hand. Okay, Zad. Abdul,
So what is range?
range, when you will put the angle, for example, if you will put 30 degree here, you will get a 1 by 2. So 1 by 2 is one of the range. Okay. So what you are putting is domain, what you are getting is range. So you can say that input is domain, output is range. Clear, for?
Yes, I got it.
Okay. But you should always get a real number. Okay. Okay. Now domain. So what we can put here so that we will always get a real number. Who can tell me what is the domain of sinusoidal function?
So 0, pi by 6, pi by 3.
Yes. But the
Triangle.
complete yes.
So angles.
Yes, all the angles.
Theta.
Anyone can tell me the complete answer? What is the domain of sine? Domain is you can put anything here. Okay, pi by 2, 0. You can see, you can check from the graph. This graph will further extend like this and so on. So the points which are there on the x-axis will give you the domain. So you can see that complete x-axis is a part of the graph. For each and every point on the x-axis, you have a graph. So we can say domain is complete R, complete x-axis, complete R. Okay, because you can see at yes, what?
So, sir, that means that for all the angles, the domain will be the axis.
Yes, yes. For each and every angle, you have a graph on the x-axis. That's why the domain will be R. Okay, Abdul? Now range. So always remember, domain you will get on the x-axis. So if a graph, if I will give you a graph and ask you that what is the domain of that, then from the graph only you can judge that what will be the domain. So just focus on x-axis. All the points on the x-axis will give you the domain. Now range. What is the range? When you will put this R in place of theta. If you will put all the angles in place of theta, then you will get the range. Okay. Range you will get on the y-axis. So from the graph, we can see that the minimum value is -1 and the maximum value is 1. So we will say that the range is -1 to 1. Is it fine? Is it clear to everyone? Okay. Abdur, Fahad, Rifat, is it clear?
Yes.
Okay, Abdur, very good. Okay, so this is sine theta. Now, if we need to find the inverse of this function, then what we will do? We will just take a portion. So we will take only from -pi/2 to pi/2 because we need to find the inverse. So we will take only this portion. Okay, only this portion. For this portion only, we will find the inverse. Why we are taking this portion? This is a principal branch. This is a standard that for sine theta, you need to take from -pi/2 to pi/2 only. Okay. Now x is equal to sine theta. Now what we will get when we are finding the inverse, then everything will become reverse. Now theta is equal to sine inverse x. This we have already discussed in the last slide. That if x is equal to sine theta, then its inverse will be theta is equal to sine inverse x. Now for this, we will draw a graph. Everything
So
will
we
be
have formula, right, for sine inverse x.
which formula?
There is some formula. I don't remember.
So 1 by root of minus x
Yeah.
square.
Sorry, what do you think?
So it's 1 by root 2, like 1 by root 1 minus x square.
I'm still not sure. If x is equal to sine theta, okay, then we will write sine theta is equal to x. Then we will get theta is equal to sine inverse x. So this sine inverse x is the inverse. Okay, now please tell me what you're saying.
So he
So
was
I was
asking
saying
that.
that sine inverse x. There's one formula of sine inverse x.
Okay, you're saying the derivative sine inverse
Yes.
x. Okay,
Yes, sir.
derivative. Okay, derivative is a different thing. Okay, in this chapter we will just study the sine inverse. Sorry, the inverse of trigonometric function. Okay, once it will be completed, then we will check the differentiation of these functions. Okay. Okay, next is sine inverse x. So when we are finding the inverse, then everything will become reverse. So angles were in the original function, angles were given on the x-axis. Now the angle will go on the y-axis. So here you have a 0, here you have a pi/2, okay, and here you have -pi/2. The values were earlier were given on the y-axis. Now it will come on x-axis because we need to find the inverse. Everything will become reverse here. If you will find the inverse of this, then the graph will be like this. Okay, graph will be like this. Now angle will go on the y-axis, values will come on the x-axis. So that's mean domain and range will also change. So if we will check for theta is equal to sine inverse, I already told you that domain will always lie on the x-axis. Now who can tell me that for this graph, what is the domain? For sine inverse x, who can tell me the domain?
So is it pi by 2 to minus pi by 2?
Minus 1 and 1.
No. Yes, sorry, Zed, that was not correct. Yes, Abdur,
Minus
what?
1 and 1.
-1 to 1?
Yes, sir.
Very good. Okay, Zed. So domain you will get on the x-axis, Zed. Now here the x and y-axis has been changed. The values has been changed. So here you have the value from -1 to 1 only. So the domain is
So,
-1
sir, it
to 1.
just gets interchanged, right?
Sorry, Abdur.
So it gets interchanged, right?
Yes. Everything will get interchanged. What you have a range here that will become the domain in inverse. Okay, Zed, is it clear? Zed, is it clear?
Yes.
Okay, great. Now, who can tell me the range?
So minus pi by 2 to pi by 2.
Very good. Okay, we will include this minus pi by 2 to pi by 2. Okay, close interval because we need both the values. So you need to remember this.
So
This is very
the range
important.
would be R.
Sorry, Abdul?
So the range would be R.
No. Why I have written here R? Because we have taken the domain of the complete function. But for inverse, I already told you that complete graph is not a bijective. So we need to just take a portion of this. So we have taken just this portion, only this one. So from this graph, you need to find the domain and range of the. Okay, so if you will check the graph, then on the y-axis, you have only minus pi by 2 to pi by 2. Is it clear, Abdur?
Yes.
Okay, if you will take R, then the function will not be a bijective function and we can't find the inverse. So domain and range will become reverse. This is very important. This you need to remember, domain and range. And once the graph will be completed, then I will explain to you how to remember this. Okay, so everyone please draw this graph and raise your hands. Then we will start with costs. Okay. Okay, Abdur, very good. Fahad, Rifat, and Zed, please confirm if it is done. Okay, Zed, good. Okay, Rifat, very good. Fahad, is it done? Fahad, is it done?
No, sir.
Okay.
Done, sir.
Okay, Fahad. Good. Next one. Next, we will do second one, which is x is equal to cos theta. Okay. I hope you remember the graph of this cos theta. So it start from here like this, like this. So for 0, it is 1. For this is pi, it is -1. Okay, and so on. So who can tell me the domain of this? Who can tell me the domain of this?
R.
Domain is?
So close interval
R.
0 to pi.
No, I'm asking about domain.
Sir, R.
Okay. Domain of this. Sorry, Abdur. You're saying
R.
R. Very good. Okay, so I have not limited any part right now. So domain is R. We are just discussing about x is equal to cos theta. So domain is R. Range, who can tell?
Minus 1 to 1.
Very good. Okay, so the range is -1 to 1. This is clear, Fahad and Rifat?
So why domain is R?
Y domain is R. Please check the graph. This will keep on continuing like this only. Okay, so if you will check that each and every point on the x-axis, you have a graph. Or you can see here in place of theta, you can put any real value. You will get an answer. Okay, Fahad?
Yes, sir.
Okay, and from the graph only, you can see the complete x-axis is a part of a graph. So sorry, the point on the complete x-axis are a part of graph. Now range, we have this. Now we will find the inverse, cos inverse x. So again, same thing. We need to have a principal branch. So here the principal branch is from 0 to pi, this portion. So while finding the inverse, we will take only this portion, 0 to pi. Okay, we will do the same thing. X and the y-axis will interchange. Sorry, the points will interchange here. So earlier you have an angle on the x-axis. You need 0 to pi. So 0 is here. The angle we will write on the y-axis, 0 to pi. Then -1 to 1 we will write here, -1 and 1. Okay. So, and we will write pi by 2 also. So we will write 1 here. Okay. So for 0 you have a 1. Then it will be somewhat like this. The graph will be like this. Okay, the graph of inverse. This one, this one.
So but at the origin it's curved, right?
Sorry, Abdul?
So at the origin the graph is curved, right? For x equals to cos theta.
Sorry, Abdul, your voice is not audible.
So at x equals to cos theta, the at the origin it's curved, right? So why for inverse it's not curved?
What you have to do, Abdul, you need to put all the values here. Okay, when you are finding theta is equal to cos inverse x, then in place of x, you need to put the value. For example, if you will put 1 here, cos inverse 1, then what will be the angle when you will get 1 in cos?
That's 0.
0 degree. So for 0, here you have a 0. For 0, what will be the value? Value will be 1. Okay. If I will write -1 here, then for what angle you will get a -1? Pi?
Yes, sir.
Okay. So this is pi. So here you need to mark this point, which is -1. If I will write 0, cos inverse 0, then for what angle you will get a 0? Pi by 2. So we have here pi by 2, where the value is 0. On the x-axis, we have a value. So you can see here on the x-axis, we have a 0. Is this fine, Abdul? Or you were asking something
Yes,
else?
sir. Yes.
Okay, so this is a graph of cos inverse. Now domain. I will ask one by one. Fahad, will you please tell me what is the domain of this?
-1 to 1.
Domain will be -1 to 1. That is absolutely correct. Next, Rifat. Good, Ziad, your answer was also correct. Rifat, can you tell me the range of this function? Rifat, can you tell me the range of this? Rifat, good, Zed. Anyone else can tell me what is the range of this function?
Pi to
Anyone?
pi by 2.
0 to pi. Okay, check the y-axis. Check the y-axis here. So the graph is from 0 to pi. Okay, so the range is 0 to pi.
So why is it not pi by 2 to minus pi by 2?
Okay, let me complete this first. Okay, so what you are saying? Why
So
not
why
minus
don't they, yes,
minus pi by 2 to pi by 2? So if we will check from the original graph here, sorry, this is 0. So this should be minus pi by 2. And this should be pi by 2. So please check here from minus pi by 2, pi by 2, this complete part is not bijective. Here you have certain angles for which the value is same. For example, for minus pi by 2, the value is 0, and for pi by 2 also the value is 0. So minus pi by 2 and pi by, from minus pi by 2, pi by 2, this function is not bijective. Okay?
yes.
Okay. So these are very important. These inverse, domain and range are very important. So please learn this. Okay, please note down this. Raise your hands once it is done. Then we will start the next graph. Okay, Fahad, good. Okay, Fahad. Okay, Abdur. Rifat and Zed. Okay, Rifat. Zed, is it done?
Yes.
Okay, great. Next one. Next is third one. X is equal to tan theta. Okay. First of all, we will draw the graph of tan. Okay, this is 0. Then here you have a pi by 2. Yes, Fahad, you need to remember, but I will give you the hint to retain these formulas. Okay. Then 0 to pi by 2. Then here you have, here you have 3 pi by 2. Here you have minus pi by 2. And here you have 3 pi by minus 3 pi by 2. Okay. We need to draw the graph of this. Who can tell me what is the value of tan 0? Value of tan 0 is what? Tan 0 is 0. Okay.
Yes.
So what you need to do, please learn all the values because we need these in the questions. Learn all the values, tan 0, tan 30, tan 60. This should be on your tips. Okay. So tan 0 is 0. We have this point. What is tan pi by 2? It is not defined. So we will draw like this. This line will never matches that dotted line, unlike this one. Okay. Because for pi by 2, it does not exist. And here also we have what? Here we have a pi. So we will draw the graph like this. Like this one. Here you have minus pi. Like this. Okay. So x is equal to tan theta. We have this graph. Now, who can tell me the domain? Domain of this function. Okay, this is your last topic of today's class. Okay, just please
R.
focus on this. No, that's not correct. Uh, tan theta is sine by cos. So for what angle cos is 0? For what angle cos is 0?
Cos
90.
90.
90. Okay, so denominator is 0 for 90 degree. So for 90, tan does not exist. So domain is R except 90-degree values. Okay, so we will write like this: 2n plus 1 pi by 2. R except 2n plus 1 pi by 2. In place of n, you can put any integer. So it will become an odd multiple of pi by 2. If you will check here, then for pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. For the odd multiple of pi by 2, the tan do not exist. So R except 2n plus 1 pi by 2. Who can tell me the range? This is the last topic, okay? Just focus on this. What is the range?
So minus 1 and 1.
No, you can see a range will be given on the y-axis. So you can see complete y-axis is a part of the graph. So range is complete R. Okay, check the y-axis.
How?
Check this y-axis. For each and every point, you have a graph. You can check here.
So can you explain this domain part?
Domain, okay. So tan does not exist for which angle? For
90 degrees.
90 degree, okay. 90, 270, or we can say pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, not even multiple, okay? Because if you will put a even like this, then it will cancel out and will give you pi. So always take the odd multiple of pi by 2 like this. So if you need to form this formula 1357, then you can write 2n plus 1. This clear for
So sir, what we have to put in place of n?
any integer? You can put any integer, 0, 1, 2, 3, minus 2, minus 3, any integer, not decimal or fraction. Clear for?
Yes.
Okay. Now the range is complete R. Why it is R? Because you can see on the y-axis, all the points on the y-axis, you have a graph. Okay. So the range is R. Now we will draw the inverse of this. Inverse is what? Theta is equal to tan inverse X. Okay. Again, the same thing. What principal branches? I have shaded the portion with green line. So we need to take the green line only. So I will draw the graph for you. So that means you
So
need to
how are
take
we finding the graph for tan inverse x?
how I'm going to find this.
No, the graph for tan inverse x.
So let me draw this first. Okay, again the same thing. Whatever the values you have on the x-axis, take that on the y-axis. So principal branches from minus pi by 2 to pi by 2 for tan. So this you need to learn the principal branch. Okay, so we will take these angles on the y-axis now. So what we will take? Minus pi by 2, and here we will take pi by 2. Okay. Next, the values which are there on the y-axis, we will take on x-axis. So complete R we have taken here. We will draw the graph. So let me draw a shaded line here. Let me draw a shaded line here. We need to draw the graph here. So yes, draw like this. It will not touch the shaded line. Okay. For 0, it is 0, and like this. This is the graph. Now we will first of all find the domain. Who can tell me the domain of this tan inverse? Who can tell me the domain?
So r except 2n plus 1
No,
pi
no,
by
no.
2.
Oh, no, no, no. What the range is in tan, the domain will be that. So domain is R. Okay. If you will analyze this function, then you can see on the x-axis all the points. All the points, you have a graph for all the points. Check here. For all these points, you have a graph here. So domain is R. Who can tell me the range? Check the y-axis. For what angle you have a graph?
So minus pi and pi.
Minus pi by 2.
Yes.
Minus pi by 2 to pi by 2.
Okay, minus pi by 2 to pi by 2. But we know that tan inverse do not exist, sorry, tan do not exist for pi by 2. So we will take an open interval. Okay, we will not take the close interval. We will take open
The
for
range once again.
range. Yes, yes. Check the graph. If you will check the graph of tan inverse, check here minus pi by 2 to pi by 2. On the y-axis, you have only this angle minus pi by 2 to pi by 2. Okay, and you know that for tan do not exist for pi by 2 or minus pi by 2. That's why we will write the open interval. Is it clear up to now?
Yes, sir.
Okay, so I will give you the hint to remember this domain and range. Okay, of this of this inverse trigonometric function. Okay, so please note down this, raise your hand. We will continue this tomorrow. Okay, Zad, very good. So Zad, if you wish, you can drop, but tomorrow you have a test of maxima and minima. Okay, so please be prepared for that and complete your homework. Yes, Abdul?
So we have test on the first, based on first derivative, second derivative.
Abdul, the second derivative test is simpler than the first one. That's why we have done many questions. So that's why the word problems we have done by second order derivative. Okay, so I suggest you to please use second derivative test in all the questions. In case it fail, you know the exception. In case it fails, then go back to the first derivative. Okay.
Okay, sir. Thank you, sir.
Okay, you're welcome. So please note down this, raise your hands, and complete your homework till tomorrow. Okay, Abdur, very good. So if you wish, you can drop off. Okay, Fahad, if you wish, you can drop. Rifat, is it done? Okay, great. So if you wish, you can drop off. We will continue this tomorrow.
So we just have to by add the values, right? So,
Yes.
so we just have to by add the domain and range, right?
Yes, but I will give you the hint to learn this range.
Yes, sir. So we don't have to remember the graph.